Alright guys, so we're talking about impulse, and we call it a fancy name, impulse, but really it is just simply a force that acts on a certain time. And when you put a force on an object, we know that F equals ma. If you put a net force on an object, it's going to accelerate, it's going to change its motion, which really just gives us F delta t equals m delta v. Alright, now this presumes a big deal, which is one thing we haven't said, which is we're assuming it's a constant force. You're pushing it on the same all the entire time. Friction is the same the entire time. The pull of the car engine is the same the entire time, which is sometimes true, but not always true. So let's look at it a different way. What if we have a graph? Force versus time. All right. Now we'll start super simple. Let's have a nice constant force. A 10 Newton force for 5 seconds. Impulse is force times change in time. So in this case it's super easy. The force is 10 the entire time. The time is 5 seconds, so it would just be 10 times 5 is 50 Newton seconds. But look at it a different way. What did I just do? I took the length times the width. And length times width is the area. So another way of finding impulse is to use the area under the curve. Oops. So if we have a force versus time graph, you can use the area under the curve to get the impulse. For instance, what if you had this? Force, time, 2, 4, 6, 5 newtons. The force varies. It's not the same at each point, but we can still get the impulse. We can still see how much of a change of velocity we have simply by finding that space. So we'd have a triangle, 1/2 the base times the height, plus a rectangle, plus another triangle. So 2 times 5 plus 2 times 5. So we get, in this case, 20 Newton seconds. Now, just because we stop there doesn't mean the problem's over. This could be asking about a change in velocity. And you just, now that you have the impulse, you plug it in exactly where we've used it before. Now, really, we give impulse a big name. We're like, woo, impulse. We've got a force versus time graph. All right. Have it increasing. We've actually seen this graph before with just a subtle little difference. Force is m times a. Let's just get rid of the m for a second. Pretend this is a graph of acceleration versus time. What's the area under a curve of acceleration versus time? Oh, that's change in velocity. So the only reason it becomes an impulse is because there's an m there. So the m is here, so we get mass times change in velocity. This is something we've been doing since the first time we started motion. It's just got a new name.